Hi all, welcome again to the next tutorial of the session. Let's not do the delay and I'm going to share my screen. Last time we have done half of the code and the half will remaining. Let me share my replit with you all. So as you all can see my screen, last time we have done the class that will be the car. We have initiate the init method inside the class, which is having all the variables and we are connecting all of them with the remaining function blocks over here. The function we have done is was display car self and crash check self. Now, the next function that we are working with is for, updating the sensor data. So what updating the sensor data is, I let you know, but first let me show you all the code for updating sensor data. Over here, if you will see, this line of code, it's updating sensor data. There is a comment also that this will update the point of data. So this method is actually responsible for the sensor data of the car. Okay. This sensor data includes the distance from the car to edge of the track at specific angles. Okay. The sensors we are using over here, these are obviously virtual and we are simulating this self-driving car. So our car has to sense the surrounding, like distance, the obstacles or boundaries, right? So that's why we are making this updating sensor data as a function. Now let me explain you in detail for this. Over here it says that angle is equals to 360 minus self dot angle, 90 minus self dot angle, 180 minus self dot angle. Okay, what is this? Basically, we are defining the sensor angles. Like if my one sensor is working, at what angle it is working. If my second sensor is working, at what angle it is working. So if I'm saying that 360 minus self dot angle, it's directly in the front of the car, right? Of course, 360, if I'm taking a turn of 360, it means if my face is towards forward, right? At the front. So if I'm taking a turn of 360, it will be at the front. So of course, it is the front of the car, right? If I'm saying 90 minus self dot angle, it's perpendicular right side of the car. If I'm saying 180 minus self dot angle, it's directly behind the car. Of course, 180-degree turn, it's exactly opposite where you are standing. So it's directly behind the car. So these are actually the angles that then converted into the radians. As I already told you, math.radians we are using over here for tracking the coordination of that particular car, right? So the function we requires in angles as radians, right? Afterwards, what is the next step? When we are setting up the angle in form of radians, like in the second line, first line, we are setting the angle for the front, right, and back. In the second line, we are converting into the radians. Now we have two empty list, edge points and edge distance. Okay, so what these list does and why we are initializing these lists. So obviously these lists will, the edge point is the list that will store the coordinate of the point where the sensor hits. Okay. So at what boundaries it hits, it will actually having all that points inside that empty list. Now what is edge distance? The edge distance is this will store the distance from the car center to the edge point. Like uh, from the center to the edge point, what is the distance it's having? So the points is storing in edge points and the distance is storing in the edge distance. Okay. Afterwards, what is the next step? We are having a loop. So we are taking for angle in angles. So there is a angles. So in this, I'm just taking the variable angle, distance equals to 0, edge x, edge y is equals to car dot center. And we are having one more loop while track copy dot get at is not equals to white color. As I already told you that if this track is not equals to white color, then what will happen? So, but how we are actually putting this condition beyond? First, we are using the for loop is that for each sensor angle, the method start at the center of the car and move outwards in the direction of that particular angle. Okay. In while loop, it keeps moving the sensor onward, outwards, and until it hits the edge of the track, which is defined the point and within the white color in track copy. Okay. So how you are detecting the edge? You are detecting the edge like edge x, edge y coordinate you have with the particular angle units, and track dot copy get at edge x, edge y equals to white color. So this sensor actually reaches the point on the track of the boundary where you have given that particular code or that particular command. Okay. I hope this thing is clear to you all. Afterwards, what is the next step? The next step is actually we are giving the explanation to display edge point or update position method. Okay. So how we are going to update position and display edge points for that particular part. So I'm going to write down the code for that also. Just wait. This is my, so make sure about the spaces. If you have done the complete course of Python till now, you will get to know about that particular thing. So we are having this defined display edge point, that is self. Okay, what is that? And how we are doing that? So this method is responsible for visually representing the car sensors on the screen. Like each sensor detects the distance from the car to the nearest edge of the track. Okay. And that's why we are actually storing self dot edge points, and these distance are actually stored in that particular part. So what steps we need to follow for this? For each point, like self dot edge point, that is having the sensor line hits the track edge, we are having draw line and draw circle. Okay. So from the car center to the edge point, we are using the line that is green color line. My car will start from particular point, and when it's overall covering the track, when it hits the green line, green color line, then something is going to happen. Okay. And draw a circle is what? Like draw a circle is act to visual indicator for the edge of the sensor. Circle is the sensor edge. So it's actually visually indicating ki okay, this is the edge circle. Okay. So this help to visualize the sensor in action and allowing you to see how far the car is from track edges in real time. Okay, like how it's going to be real time from the particular track edges. So this is draw line, draw circle we have done for detecting the sensor and for the points. Now, how we are doing updating the position of that particular car. So how we are updating? the updating method is actually responsible for updating the car position, as you all know, and location of its corners. That is used from the collision detection. Now, what steps actually we are following over here? First step is we are translating the car's center. So car's position is actually updated by moving it forward along the direction it's currently facing. So this is actually done by the translate point, and we are having the degree of angle, right? 90 minus self dot angle. So it will actually adjust the angle where the car is moving at particular distance. Okay, that is delta distance. Now the distance of the car is traveled is accumulated in the self travel distance. Okay, this is how the translate of car's center. Key, there is a center and how it's going to translate throughout the track. Now calculate the car corners. How we are calculating? So if there are four corners of the car, and of course these are updating on the new center position, right? See, I'm tracking actually the car position. So center say to I'm updating it accordingly. But for how long I can simply update the corner coordinates of the car. Of course, according to the center, when the center changes the corner of the coordinate, these four corners of the coordinate will definitely going to change. So how we are doing that? We are actually treating the car corners as a rectangle, and we are calculating the moving from the center of four directions. Like we are having four directions: 60 minus self angle, 120 minus self angle, 240 minus self angle, 300 minus self angle. So we are having four direction and we are calculating it accordingly. Okay. Don't go deep. If you know the mathematical concepts, it's fine. If you don't know, you have to understand like this way only, because this is the only way for letting you understand. Okay. Now, the distance to the corner is half of the diagonal of the car. So, which is computing using the Pythagorean theorem. Pythagorean theorem क्या कहती है? SQRT is the square root of the car size index 0 will be the power of 2. So double asterisk means power of 2 plus the car size of index 1 will be the power of 2 should divided by 2. Of course, I think you have done the text reading, like the picture that convert from picture to text. So this algorithm works according to that one. So if you want to check, you can go and check that project. So this is how we are tracking the boundaries of the car and car position. We are updating accordingly and regulating the car position. Now the next point that you have is the visualization. What is visualization and how this visualization is going to work? So first thing, this is absolutely fine. Like I told you, this is the algorithm we are putting. Now how we are doing the visualization. So we are having display edge point and update position. Two things we are having. Okay, like we are updating the position, also we are displaying the edge point for that particular point. So the rest part of the code, I'll let you know how we are going to do. But this is very long code and still we are having some remaining code. So that we'll cover to the next class. Till then, just be updated. If you're not aware with the mathematical concept, please go and read so that it will be clear for you all. And thank you.